Okay, now we're looking at section 8.2, number 12, and this is one of these where it's kind of cute what happens as you're working it, so you just kind of pay attention to what's happening. So it says to integrate e to the 8x cosine 3x dx. All right, now you should know that you can't use your cute little thing where it goes down because you don't, neither one of these will differentiate down to 0, but they're both pretty easy to integrate or differentiate. What you would do is you have to just pick one to be u and one to be dv, and I don't know that it matters, but I'm going to choose u to be cosine 3x, and then dv is equal to e to the 8x. All right, and so then du is, the derivative of cosine is negative 3 sine 3x dx, and then v is going to be 1/8 e to the 8x. All right, and so then this integral, and it's important on these ones to actually write what you started with. So the antiderivative of e to the 8x cosine 3x dx equals uv, I'm going to put v first because it looks better, 1/8 e to the 8x cosine 3x minus the integral of the voodoo, which is 1/8 e to the 8x times, okay, this will be plus, and there'll be a 3 here, sine 3x dx. Okay, and so you're going to need to use integration by parts again with the same pattern that you had on this one for this part of it. So let u equal sine 3x, then du is equal to 3 cosine 3x dx. And then if I pull this 3/8 out in front, then dv is just e to the 8x again, and then v is 1/8 e to the 8x. Okay, so this right here is the integral of e to the 8x cosine 3x dx. And that's equal to 1/8 e to the 8x cosine 3x plus 3/8 times uv, which is 1/8 e to the 8x sine 3x minus the integral of the voodoo. The integral of the voodoo is going to be 3/8 cosine e to the 8x cosine 3x dx. So the trick on these problems is to recognize that this is basically the same animal as this. So you can collect it. Like this is like, if this were 5x and this were 2x, you can bring them together, right? So it's hard to, I don't have this all on the video, but anyway, I'm just going to clean up this side. This is 1/8 e to the 8x cosine 3x plus, okay, this is going to be 3/64 e to the 8x sine 3x minus 9/64 antiderivative e to the 8x cosine 3x dx. And so what you have to recognize is that this right here, you have negative 9/64 of that right here. So you're going to move this over to this side. And this is a whole one, and you're going to add 9/64 to it. So you're going to have 64/64 plus 9/64, which is 73/64. Does that sound right? 73/64 of this thing is equal to this thing. And so then in order to solve for this, which is what you're looking for, you just multiply by 64 over 73 on both sides. And of course you have a plus c. And so then this will be, I guess you could distribute this through. So this is going to be 8/73 e to the 8x cosine 3x plus 3/73 e to the 8x sine 3x plus c. I wonder if I'll get it. So 8/73 e to the 8x cosine 3x plus 3/73 sine e to the 8x sine 3x plus c. What do you think? Okay. All right, so that's just another, that one, that's that other thing in the integration by parts. There's kind of three things. There's just the basic integration by parts, and then there's that cute integration by parts where one of them will go down to 0 and you can use your little diagonals. And then there's this where you end up, your new integrand has the old integrand in it, so you move that over and it's like a little technique. You move it over and you see it. So that's a kind of a fun little thing.